This is systems with two variables and story problems. We're going to basically be doing an Algebra 1 lesson to kind of re-emphasize, reintroduce some of these Algebra 1 concepts because they are vital for the later parts in this Algebra 2 lesson in this entire unit, so of matrices. So learning objectives, we're going to solve systems of linear equations by substitution and elimination. We're going to also throw some graphing in there as well. Solving applications using systems of linear equations. So first and foremost, we've got to define what the systems of equations are. Again, this is an Algebra 1 lesson, and hopefully you guys remember this. If not, you might have to go through this video a few times. But what a system is, it's a set of two or more equations. In Algebra 1, you guys kind of started off with the system that basically had two equations. We're going to get into more equations when it comes to Algebra 2. So a solution of a system, it could be an ordered pair that makes the equation true, or it's also defined as the point on a graph where the functions intersect. Now there's going to be three possible solutions that can actually occur, and we'll show that in a few seconds. So ways to solve systems. Again, these are Algebra 1 techniques that you have used. The first way, which we're going to go over, is graphing. You get it into y equals mx plus b form. You look at the equation. You say that your m is 2 and your b is 1. You graph it from there. You could also say this is 2 over 1. Graph the y-intercept. From there, you go up 2 over 1 and graph the next point, and you do the exact same thing with this equation, and you see where they intersect. So that's graphing. Substitution, if you notice here, you have one of the equations is solved for a variable. So this x is by itself. So you use this when one equation is solved for a variable. With elimination, you have basically both of the x's and y's on the same side of the equal sign. So both are on the left side, both are on the left side. You can use this, like I said, when all else fails. And basically the technique of elimination we will go over. But again, these are all three Algebra 1 topics. So types of solutions, these are your three possible solutions that can occur. If you graph the lines and you see that they intersect at at a single point, namely here, and you say that that point is 1, 3, you say that that's one solution. We also call it a unique solution. The next thing that can happen is infinitely many solutions. Let's say you have the line, y equals 2x plus 7, and then you have another line that's y equals 2x plus 7. Technically, these are two different lines because they're two separate ones, but you figure out when you actually graph them that they end up being the same line. So they basically overlap. So if they overlap, they intersect each other at infinitely many places. So we say they have infinitely many solutions. The other thing, or the last thing that can happen is no solutions. So if you have parallel lines, lines that do not intersect, they will have no solution because they will never intersect. This line here will never intersect with this line here because they actually end up having the same slope. Parallel lines have the same slope. Maybe something you want to remember from Algebra 1. So, three possibles. Unique solution or one solution. You have infinitely many solutions or no solution, which means parallel lines. Okay, so we're going to start this off by graphing, and you have to have some sort of a way to distinguish and have an organized way in actually doing these. The way I'm going to do it is I'm going to number these, but I'm also going to use color coding. For example, the first one that I graph, my my slope is 4 over 1, and my y-intercept, my b, is going to be 3. So I start off at 3. Again, this is Algebra 1. From here, you go up 1, 2, 3, 4 over 1, or down 1, 2, 3, 4 over 1, and you graph the line. So in terms of graphing the line, you need at least 2 points. 3 is probably better, but you want to get it to where it's enough to where you can have it across the entire graph, just because it's going to be easier on your part. If you don't have color coding, what I would suggest doing is labeling numerically. So for example, I'm going to do number 2. Number 2 has a slope of 2 over 1 and a y-intercept of -1. And I start off at -1. From here I go up 2 over 1, up 2 over 1. I do have some students, what they like to do is they like to graph all of their points using the slope across the entire x-axis or entire graph. And the main reason is because it's just easier for them to do that. So in this case, what I'm doing is graphing as much as I can, but where I see they intersect is at this point right here. If you graph these accurately and with a ruler, you will see where they intersect. So in this point, what I can say is that my solution, since it's right here, my solution to this is going to be the point -2, comma, -5. Because I go to the left 2 and down 1, 2, 3, 4, 5 to get to that point. So what that basically means is this is a unique solution. The last thing I'm going to make sure I do, again, distinguishing the two graphs with numbers. You could also distinguish the two graphs lines with colors as well. All right, so if you want to pause the video and try this on your own, you can do that, but I'm just going to go through this a little bit quicker. I'm going to do this first one. Mainly the main thing that mixes people up is this part right here, because they don't realize that since there's no y-intercept, that the y-intercept is actually at 0. That's something that kind of trips some people up. So I'm doing this, like I said, a little bit quicker because this is an Algebra 1 topic. It's something expected to be known in Algebra 2. So when I graph this line, you want to be as accurate as you possibly can, because not accurate means you can't actually see where the graph intersects. So that's my line 1. Here's my line 2. My m is -1. Some of you guys are probably already saying, I know the solution, I know what the answer is, which is awesome. But if I do this just to graph it, make sure that I do it correctly and accurately. I have my two lines color-coded. And again, if you don't want to use color coding, that's fine. You can use numbers, but I would highly suggest you have some sort of way to distinguish which line is which, because it's going to be super important when it comes to the to graphing in the future. So in this, since I see that lines 1 and 2, visually they do not intersect, I also see that they have a slope of -1. Both of them have a slope of -1, so this is no solution because both the lines are parallel. Okay, so this third one, if you would like to pause the video, I'm not going to go through this in detail because it's basically the same thing as number 1 and number 2, but you can pause the video and do it on your own and then check and see if your answer is correct, and I will display the answer in just a few seconds. Here is your solution. Notice that I notated the different colors and also labeled the different lines. So your solution, this is a unique solution of 2, 1. All right, so we're going to now use the technique of substitution, and I have a specific way that I like to do this just because I think organizationally it's kind of nice. So if you like it, cool. If you have your own way that you like to do, fine by me. Pick and choose whichever works. What I like to do is I like to have kind of a T table here, and just to kind of separate these two equations. And I look for the one, because in substitution you're trying to find the one that is solved for a variable. I see that x is solved. It's by itself on its own side. So what I'm going to do is I'm going to take this equation and I'm going to draw a line to the x. The reason I'm drawing a line to the x is because what does substitution do? What does a substitute teacher do? They take the place of the teacher. So that means this x that was here is now going to become the 2y plus 2. It's substituted. And then you just solve it like you normally would. So we got -6. Let's keep the coloring accurate. So -6y plus 6 plus 4y equals negative 4. Collect your like terms and watch your arithmetic here, your basic math in terms of solving. I subtract, I get negative 2y equals negative 10, and y is equal to 5 when I solve. Now what I like to do is I like to say, okay, so since I've solved there, I'm going to draw an arrow to my variable that I need to plug this into. And the reason is because I get some people, some kids, that mix these up. So for example, we got x equals negative 2. My y now becomes what I just solved for, which is 5. That's one of the reasons why I drew the variable line here. You don't have to go this intricate, but this is just for understanding's sake. So we got negative 10 plus 2, and your x is equal to negative 8. Now since I have two solved parts, two solved variables, my solution to this will be negative 8, comma 5. And you can always check, and if you want to, and plug in your x into here, your negative 8 into here, and your 5 into here, and see if you get negative 4. You should. And the same deal here, if you want to plug in negative 8 into here and 5 into here, you should get a true statement. You don't have to do that, but that's just kind of a check. So there is your unique solution. So go ahead and try this one if you'd like to. This one's a little bit trickier, just a little bit, just because you have a choice. I know that's kind of tough for people when they see, oh, I have creativity that I can do. Well, my first equation here is x equals 3y plus 2. And I do my t-chart just like I do, and I have x equals 7y minus 2. If you don't like doing the t-chart, you say it's too long, I'm not going to mess with you as long as you're doing it correctly. And like I said, I will not mess with you. So we got 7y minus your 2. That equals a 3y plus 2. So I basically substituted this guy here, became that. And now I solve. So I'm going to subtract the 3y on both sides. So I got 4y equals, and I add the 2, I get 4. And I divide, I get y is equal to 1. And there's my y value. So now I'm going to plug in, draw my line, or my arrow, into the y, because now y is going to become 1 minus 2. So we got x equals 7 minus 2, which gives you 5. So now I have the point 5, comma 1 is my solution. And again, you can check it by plugging it into each one of the equations and variables. Okay, so the next thing is elimination. So elimination is, there's many different ways of using elimination, but elimination basically has both of the variables on one side. You notice both of the variables are on the left side. What I tell my kids to do that have trouble with this is literally just deal with the x values, if that helps, and just say, okay, I need to get opposites in front of the x values. Well, what do I have to multiply the top equation by to get a value opposite in front of the second equation? So I'm going to multiply that by negative 2. And again, this is an Algebra 1 topic that I'm expecting you guys to be able to revisit since you're in Algebra 2. And that equals negative 26. And then this 4x minus 5y equals 8 does not change. The way that I tell kids to do that is what I think is the way that is more complicated, but I think it works all the time. You look at whatever these numbers are and just multiply the top and the bottom by those opposite numbers. And like I said, it's going to be more work, but if you can see the shortcut like you should be able to see in Algebra 2, it's much easier. So these guys go away. You're left with 3y equals negative 18. Divide by 3, and we got y is equal to negative 6. So that's your y value. I tell my kids to always use the top equation just because it's easy to remember. Yes, you can use the bottom equation if you want to. If you're one of those ones that wants to just kind of go with a little bit of creativity. But I always tell my kids, use the top equation because you don't have to remember much other than just use the top equation. So we got 2x minus my 4 times my y value is now negative 6, and that equals 13. And now solve like you normally would. So we got plus 24 equals 13. Subtract, you get 2x is equal to negative 11. and then x is equal to negative 11 over 2, which is not a nice number, negative 5.5, but it does work. If you plug in negative 5.5 or negative 11 over 2 in for your x value and negative 6 in for your y value for each one of these, you will find out that it is a true statement, and that's a check. But your final answer is this solution. This has a unique solution. Okay, and again, does not matter which one you pick. I'm going to kind of go just for improvisation's sake. I'm going to look at my y values because you have to get comfortable with looking at different variables. So what I'm going to do is I'm going to multiply the top equation by 2 because that's going to get rid of the y values. So I got 2x minus 2y equals 6, and then my bottom equation does not change. Negative 2x plus 2y equals negative 6. And if I add straight down, this goes away. Ooh, this goes away. Ooh, this goes away. So I get 0 is equal to 0, which is a true statement. Now, if you look back in your notes, when we found a true statement was mainly when you had the same line overlapping. So I got 0 is equal to 0, which means these are the same line, which means infinite solutions, or infinitely many solutions. It's completely up to you how do you want to phrase that. But infinite solutions is fine. All right, so now we get into what everybody absolutely hates in Algebra 1 and in Algebra 2 and in math class in general, which is word problems. And there's no easy way to do these except for you just got to practice these to get more comfortable with them. The stepwise approach that I say to do is, first thing you want to define your variables. Before you read the problem, write down, define your variables. So let's now read the problem. It says, Sally has some $1 bills and $5 bills in her purse, which means those are your variables. Usually your variables are defined in the first or second sentence. So I'm going to say my x value is amount or number of $1 bills. My y value is number of, I can do this, $5 bills. Put it properly. So we have two variables. So that's done. So that's defining of your variables. Second thing is you're going to want to set up your equation. And usually your equations are in the next sentences. So they're in basically back-to-back sentences. So what I do is I say, okay, she has a total of 15 bills. Okay, so if she has a total of 15 bills and I have x is equal to $1 bills and y is equal to $5 bills, you have x plus y has to equal, well, 15. Because of this statement here. She has a total of $15 or 15 bills. The next statement is they are worth $47. Well, if I take the number of $1 bills and I multiply it times the worth of those $1 bills, which is 1, plus the number of $5 bills, and I multiply that worth of $5 times each one of the $5 bills, that will give me a total of $47. So I have in the first one, I have the amount of bills, and the second one, I have the worth of those bills and what they total up to. So now what I can do is I can use elimination. You can also use substitution if you want to, but I think elimination is the easiest one to use here. So what I'm going to do is I'm going to multiply the top equation by a negative and add straight down. So these guys go away. I'm left with 4y equals 32. Divide and get it y is equal to 8. Okay. So I guess your third step could be to solve. So now you're using elimination or substitution. And I tell everybody, like I said, use the first equation, x plus y is equal to 15, and you plug in your variable that you just found. So you get x plus 8 equals 15, so that means x is equal to 7. And fourth step, and this is a step that I think mostly kids are pretty decent at doing, is writing this in terms of a sentence. Are you going to be required to do this? I would get into the habit of it because in standardized tests they like you to do this. But we have 7 $1 bills and 8 $5 bills. That is your answer. So the sentence, just because it's a little more professional to put it in a sentence. And there you go. So to recap, first step, define your variables. Do that first. That's huge. Once you do that, it gets a little bit easier. You set up your equation, you solve your equation, and then you put it in terms of a sentence. Okay, so let's use that with this one, which is a significantly harder problem in terms of the numbers, but the technique is the same. So before I even read the problem, I'm going to set up what my variables are. So define variables. Okay, so I'm going to start reading. So Richard's Sporting Goods received a shipment of 124 golf bags. Okay, so I know I've got golf bags, but it doesn't tell me. Usually you're looking for two things because word problems. Oh, and look at this. There are two types of golf bags, full size and collapsible. So that means that's your variable set. So X is full size and Y is collapsible. All right, and you can say number of, and that's fine. I'm just kind of defining and trying to keep it a little bit easier. So we have 2. Now you're going to set up your equation. Well, this is where gets a little tricky in this one, because I actually already have one equation that I can set up, because in the previous part, that 124 was given to me. That means if I take the number of full size plus the number of collapsible, I should get 124 golf bags. Okay, so this third part to this, the full size costs $38.50 and the collapsible is $22.50, and the bill from the supplier is $34.30. That's just like your $1 bills and your $5 bills. So what you're going to do is you're going to take $38.50 times the number of full-sized plus $22.50 plus the number, or times the number of collapsible, and that will equal your $3,430 that you took in. Now, this is, like I said, numerically, and I would say this is tricky in terms of the numbers that you're given, but you do it the exact same way. The nice thing is that these are ones here, so you can just basically take this number or this number and multiply the top equation by the opposite. So what do I mean by that? Well, what I'm going to do is I'm going to take the top equation and multiply that by negative 2250. The reason I did that is just because I saw that 2250 was a little bit smaller. You could absolutely 100% do the bottom equation, 3850, if you wanted to, the what's in front of the x value. It is not important because this is where the creativity comes in. But copy down that equation that you did not alter, and the top equation now becomes negative 2250 x plus, or minus, you can say, minus 2250 y, and that equals, now 2250 times 124 is something you're going to have to use a calculator for, but I got negative 2,790. Now you add straight down. So here's where your third step is. You're solving the equation, and in this case I get 16x. These guys go away. When you're using elimination, one of them should always go away, and you're left with 640. Divide, you get x is equal to 40. So that means I'm going to solve and use the top equation. So we got x plus y equals 124. Well, my x in this case is 40 plus y equals 124. So when I solve, I got y is equal to 84. So now I have my two variables. So I'm going to put my fourth step in putting this into a sentence form. So I have 40 full-sized and 84 collapsible golf bags. And again, at the beginning, if it helps you to put number of, that's fine. Or you can just kind of keep it simple, because usually people know number of, it means it's what its meaning is. So there you go. All right, last but certainly not least, if you want to pause the video and try this one on your own, you're more than welcome to do so, or you can just kind of go along with me as I go. I'm going to do the exact same thing. So I'm going to do define my variables. So you collect baseball and football cards. Bam, there are your variables. So x is baseball. And if you want to put number of, that's fine. Y equals, let's do number of football. And if you want to put cards, that's fine. I'm not going to be too specific with that. This is just to help you set up the equation. So it says, your uncle has an old collection of 360 cards that he gives you. There is your first equation. So your x plus your y, your baseball plus your football, has to equal 360. Now this one kind of is tricky. I'm not going to lie to you. So the collection has more baseball cards than football cards. Okay, so that's important, but this is what's really important and what kind of throws some people. It says, in fact, it has 30 more than twice the number of football cards. So what that means is that your baseball cards is equal to 30 more than twice the number of the football cards. So twice the number of the football cards plus 30. Now, since I have this, that's my equation here that I set up from that part of the word problem. What you can do, and again, you can do your t-table if you like, if it helps, and I'm going to kind of set it up here just because I think it's a little bit easier to do in terms of the t-table. That's just me, but again, if it confuses you, that's fine. But what I'm going to do is I say, okay, well, this is already solved for x. That means I'm going to plug this in, and I get 2y plus my 30 plus my y equals 360. I got this little part here I'll erase. And then you solve like you normally would. You got 3y equals, I'm going to actually subtract the 30, so I get 330. Divide. Notice I'm not showing the division and the subtraction because you've had Algebra 1. You know or should know how to do that. So it's just kind of one of those things that is a time saver. And now I'm going to draw my arrow to the variable I plug this in, because again, I have some people that plug it into the wrong variable because they don't have that visual that helps their mind. But we have x equals 2 times your y value, which is 110, plus your 30. Okay, so then we have x equals 220 plus 30, which is 250. And there's your x value. So your second was setting up the equations. Your third was solving the equations. And now let's put this into fruition of a sentence. So here is your fourth step. So you have 110. Actually, let's do the x values first. 250 baseball cards and 110 football cards. And done. That is your answer. Now, I hate to be the bearer of bad news, but we did not do any Algebra 2 whatsoever. This is all Algebra 1. So if this was tough for you, that means you need to go through this video again, and you also need to make sure you do your homework repeatedly, because it is only getting harder from here on out. Good luck, and let me know if you have any questions.